over 5. Okay, and so we wish to solve that. We wish to find what values of x make that true. Now, I do something a little different on these problems than your textbook author does. So when you look at the video or see the textbook, they'll do something slightly different, and it's equivalent. What they will try to do is get a common denominator across these things, find out what the common denominator is, and multiply by it. And it's not a bad approach. The way I like to think of it, though, is instead of trying to multiply by the common denominator, is to just pick one fraction at a time and try to knock it off. And that tended to be what I did yesterday. So the first thing I see is, well, there's this 19/5 here. If we multiply both sides of the equal sign by 5, that's going to get rid of this fraction legally, because we can multiply both sides of an equal sign by the same number and still get the same answer. And so we get, this becomes 19. It's so tempting to do the cancellation right away. Do not. Distribute first and then cancel. So we've got 5 times 3x over 5 minus 5 times x over 2 equals 19. Now, in this fraction, there's a common denominator, or not a common denominator, common factor of 5 over 5 that needs to go. This still remains a fraction. But at least now we're down to only one fraction rather than 3. How do we get rid of that one fraction? Multiply everything by 2, so we multiply this side and this entire side of the equation by 2. Again, don't cancel yet. Distribute first. So 2 times 3x is 6x minus 2 times 5x over 2 equals 38. These two cancel, and now we have 6x minus 5x equals 38. 6x minus 5x is equal to x. X equals 38. And there is your solution. The thing we stressed yesterday is checking your solutions. So again, I'm going to do the quick check. Does this make any of these denominators 0? No, because there are no x's in the denominator on this example. We don't have to worry about the solution making the denominator 0. This is, in fact, the solution, x equals 38.